Welcome everyone. I'm Tongthut Aung from AIT Solutions, Asian Institute of Technology. First of all, and I will be the host for today's talk. We arrange Meet the Expert Talk series, and we invite experts in the structural engineering field and allied fields to share their knowledge and experience over an online session. Let me introduce Dr. Erol Kalkan, today's speaker of the talk. Dr. Kalkan is CEO and founder of Quakelogic. His company is providing intelligent disaster management solutions through modern software technology to prevent and reduce human and economic losses during and after natural disasters such as hurricanes, earthquakes, and tornadoes. Dr. Kalkan earned 2 M.Sc degrees, one in Engineering Seismology and another one in Structural Engineering. His doctorate degree is in Structural and Geotechnical Engineering from UC Davis, and his postdoctoral studies were conducted in UC Berkeley. He served as a guest editor for 5 special journal issues, and he is currently acting as an associate director for the Journal of Structural Engineering, Engineering Structures, and Seismological Research Letters. He has also been granted 2008 EERI-FEMA NEHRP Professional Fellowship in Earthquake Hazard Reduction. He authored and co-authored more than 130 publications. Let me welcome Dr. Kalkan to present next generation structural health monitoring and smart cities. If you have any questions, please send the message in the chat box.
Well, thank you. Thank you so much. Appreciate the kind introduction. Without further, the wait, I like to start my presentations. So I am the CEO of Quakelogic, and my name is Erol Kalkan, and I'm going to talk about, the technology that we develop at Quakelogic is basically going backwards all the way, starting from my PhD studies at UC Davis and then postdoc at UC Berkeley. And I worked for about, close to 4 years for California Geological Survey on seismic instrumentation, signal processing, the data processing. And then after I worked 11 years for US Geological Survey as a research structural engineer. And I also managed the USGS stop motion network for about 5-6 years. So I've been in this business for 16 years, mainly signal processing, instrumentation, and also structural health monitoring. So I have the problem. So the problem is, globally we have the climate change, right? We started seeing more hurricanes around the globe, and like the cyclones, right, in the Asia, and then the earthquakes is another, the issue that, we've been facing, especially in California. We have a major earthquake, overdue along the San Andreas Fault or possibly in the Hayward Fault that may affect the entire, the Bay Area and Silicon Valley, right? And the earthquakes are also a threat for other part of the world as well, right? And then, like as human beings, we spend most of our time, in buildings. And then we use a lot of, the infrastructure, right, for our daily life, including bridges, the tunnels and dams. And most of these structures are, they don't have any kind of like instrumentation. They're only like the few percentage of the infrastructure have, the sensors installed. And there is no tool available in the market that actually can effectively use the data from those, the sensors installed on those infrastructure. Right, like the bridges, the tunnels, the dams. For instance, we have about the early May. This actually second week of the May, we had a major bridge had a fatigue issue in Memphis. So there was a 6-lane, the bridge, and then suddenly they realized the main girder is, has a major crack. Right, it's basically completely, separated. Well, thanks to the redistribution, so that the bridge was, didn't collapse, but there was a major, infrastructure connecting, like overpassing to, the Mississippi River, right, carrying all the entire traffic. So that was like the major, the infrastructure, without any kind of instrumentation. And it was a, the likely situation that they realized the problem, the crack, the major girder, the beam on the bridge, right before the bridge collapsed. So what I'm saying is that, we have all this like a critical infrastructure, but without any kind of instrumentation. So our solution, hopefully okay, here we go. So at Quakelogic, we provide a structural health monitoring and earthquake early warning system. And we are using artificial intelligence and machine learning, in addition to, either on-site, the processing or cloud processing. And our promise is that, we're gonna utilize all the data from all the sensors in the structure in real time, right? And we are going to, detect the issues at early stage that even, it create like a more like a costly problems later on, right? So our technology is like a fully autonomous. We do, the damage detection, and we turn the data into an action. We cut the response time by, immediately notifying emergency responders, disaster managers, facility engineers, operators, and the business owners. So the overall idea is, to protect lives, right, and reduce liability, and also, to save time and money at the end of the day, right? So let me talk about the technology platform that we have. So we are using either the existing, the instrumentation in the structure, or, we deploy like the sensors, right, at different locations in the buildings, bridges, the tunnels. So everything is connected to either wired connection to the digitizer, right, on site, or it could be completely like a wireless solution. And we pull the data in real time from the digitizer, and we are using the edge devices. Those are the structural health monitoring. It could be like as small as a single board computer, right? Depends on how many sensors the structure has, or it could be like a, like a stack of, the servers if there is like over thousands of sensors in the structure, right? So our software is extremely, the scalable. We do have the best, the software in the market in terms of the structural health monitoring. There's no vendor, the lock-in, so we can utilize any existing, the digitizers. So it doesn't have to be like a specific brand. And, we provide real-time structural health monitoring, right? So one of the unique feature of our system is that, let's say you have a bridge, that your bridge has, like accelerometers, like distributed, right? So that's basically monitoring the vibrations, and then the motion. And in addition to that, you may have displacements, the transducers at the joints. You may have like a temperature sensors, right? Humidity sensor, the wind sensor showing the wind speed and direction, as well as, the tilt sensors on the piers. So we created a system. Structural health monitoring software is basically that can take care of all this, like the different sensor data, simultaneously. So you may even have like a GPS, the receivers, right, at different locations. We can also bring the GPS data into our platform. So with this technology, you don't need like a multiple software to basically monitor your structures. So for instance, for them, so you may have accelerometers, you may have piezometers, right, looking the water level, the pressure level, and water depth on the dam, and even like any other analog and digital, the types of sensors specific for the dam monitoring. So we can actually process like everything from all these sensors into one single platform. So our software has an API that you can request the data, or you can inject data to our the system using the API, or even if you may have some analogs, like completely manually read sensors, right, in your like it happens a lot with the dams, that some of the sensors is that they have to the technician has to go read the data manually, right, and then enter them into the how to say, like an Excel or some sort of like a spreadsheet. So our software allow the technician use a tablet that they can read the, whatever the sensor data that they are reading manually, that they can basically enter it through the, like a tablet or smartphone, and all the data is going to be, the sync immediately with the software. So our backend is extremely powerful. We can process over 1,000 sensors simultaneously, and we can create different types of alarm conditions, right? So you may have different threshold alarms for, let's say, accelerometers, and then different type of thresholds for tilt meter or displacement sensors. And we can even create voting mechanisms. Let's say you have like a couple of sensors. If all of them exceed certain threshold value, then the system goes into alarm. Or if they're the average value, right, exceeds certain amounts, then the system can go to alarm mode. So we have all this flexibility. So our post-processing part is completely written in Python, which allow us to integrate any kind of a custom modules easily to our system. So this can be even like a research, the research project. So we are, we actually completed one project in Switzerland for a Swiss railway, the bridge monitoring. That was totally a customized work with the ETH, the Zurich, with the university in Switzerland. That because our the post processing is written fully in Python, we have extreme the flexibility to create additional modules to do some the advanced the analytics. And our backend is the backend part, the real-time processing part, is extremely fast. Like for instance, I'll give you an example. So let's say we can in the bridge in Nevada, we are monitoring the world's largest the concrete arch bridge, which has the bridge itself 33 accelerometers, right? And we are gathering the data 200 samples per second from each sensor. It's basically you are talking about almost 7,000 the data points just coming from every second from the accelerometers, right? In addition to the other sensors on the bridge. So in real time, we are calculating the velocity. We are adding another 7,000 data points for velocity. We are integrating the acceleration data to the displacement. Now we are looking at the relative displacement between the deck and then the bottom of the pier. So all these calculations are done in real time, and our software is handling basically 50-60,000 the data points every second. That's how powerful the system is. And as I mentioned, we can process over 1,000 sensors easily. So sorry about this presentation. Let me talk a little bit about the alerts and notifications. So what's happening? We are collecting all this data, but at the end of the day, how are we using this, right? So as I mentioned, we set different threshold values. If the threshold exceeds, our system goes into alarm, right? And it takes about the 60 seconds to pull the data from the weight tank, doing all the the processing, and we put together a very nice, very comprehensive structural health monitoring report, event report, and everything goes into our the dashboard. And dashboard is like a web application. We even sent the process data to the dashboard, and then this immediate notification goes as an SMS message to the user. We send WhatsApp message, we send Telegram message. We also send the email, like a regular email message, right? So within 60 seconds of an event, this could be like an earthquake, or this could be like a hurricane, or this could be just like a like a daily use of the for instance bridge, right? If something goes wrong. So within 60 seconds, so we notify the users, right? And then we can also attach an action. So based on the different threshold level exceedance, so the end user will get the the action item, like what steps they have to take, right? So if it's like a moderate level inspection priority, so these are the steps that they have to take in terms of the action. Like these are the locations they have to go and check. So we can create those custom action items as well. So let's see. So we are also not only another unique part of our software is that we are not only monitoring the structure, but we are also monitoring the earthquakes around the structure. Like in US, we do that by listening to USGS, the earthquake server. It takes about 30 seconds for US Geological Survey to identify the location and magnitude of an earthquake in California. And we basically we listen that server real time. And like for instance, for this bridge, we look at 200-kilometer radius of the structure. If there is an event magnitude 4 and above happens, then our system, picks that information and goes into the alarm mode, regardless if the structure is okay or not, right? So there's an event happened, there's an earthquake happened, and system automatically triggers, it calculates the wave arrival time to the bridge, from the epicenter of the earthquake, and goes back to that, the time, the snapshot, right? That captures the seismic event happen on the structure, recorded on the structure, right? And then do all the processing, and then we send this notification to the user, including the earthquake information. We provide the map location showing the epicenter of the earthquake, and how far the structure is from the earthquake, and also the snapshot. So this is how basically we relay the message to the user right after an earthquake. So in terms of the feature, we have very advanced analytical features on our software, both system features and the computational wise. We use AI and machine learning. We can calculate real-time interstellar drift especially for buildings and bridges. We can calculate real-time torsion rocking, right? We have a specific module that look at the wave propagation in the structure. Let's say if you have a concrete building, right? So we can look at the wave propagation patterns continuously, and if we identify any changes in the shear wave propagation in the structure, that may indicate like a potential damage in the structure, right? So that's the overall objective of that module. We obviously do model analysis, right? Like look at the mode shapes, the curvature of the mode shapes, as well as the model frequencies, model damping values. We calculate the base shear capacity versus the demand. So in addition to time domain analysis, we do a lot of different we have a lot of different analytical tools in the frequency domain as well. So these are all the the list of stuff that basically we are doing, and we constantly adding new advanced modules into our let's say toolbox, right? So in terms of the system features, so we do have the dashboard. That's basically you can open up the dashboard on your smartphone, and it's going to look like an app. We can provide the multi-level reporting. We understand that not everybody has the same technical background. Our system can generate 3 different types of the reports at the same time. So when the user registers to our the dashboard, so they have an option to select what kind of report that they would like to get, right? So we have like a basic report, like from one summary, non-technical summary, and then we have a mid-level report, and also very comprehensive report for basically for consultant engineers like earthquake engineers, right? So we have that flexibility as well. We have a very powerful watchdog system that basically, so when we monitor a structure, let's say we put our system, we deploy our software. So our watchdog constantly check the structural health monitoring server operations, right, to make sure that every module is alive and up and running, right? So we check the server state of health. We also check if there is any sensor has any issues. Like as soon as we the system can quickly identify if any of the sensor is malfunctioning and not sending the data, and notify us. So this way we can take action, right? We can take that sensor out of the analysis, and we can notify the user that that specific sensor is not working. So our watchdog is continuously monitoring the entire operation of the structural health monitoring system. So in addition to that, like as I mentioned, our platform works with various type of sensors, including accelerometers, the strain gauges, the weather sensors, the GPS, the load cells, you basically you name it, right? And we also regularly, actually daily basis, collect ambient data as well. And then system process the ambient data. This can be fully customizable. For most structures, we collect like 5 minutes of data at the midnight time when like it's quiet, right? And then we save those ambient data on the repository, and it also goes to the dashboard as well. So it's always available to the user, and then user have also another option on the dashboard. With a click of a button, they can put the system into ambient mode and basically pull the data anytime, right? Process it and then comes back to the dashboard as well, like to be downloaded. So these are like the main features. So in addition to structural health monitoring, we combined earthquake early warning with the structural health monitoring as well, right? So we have two different types of solution for earthquake early warning. One is very similar to so what USGS is doing in California, Oregon, and Washington. It's a shake alert system. So our system is very similar to that one. It's a network based. Like for instance, if you have seismic stations, or if you have like a multiple dams, right, instrumented, so we can utilize the data from those structures to create a network-based, the earthquake early warning in addition to structural health monitoring. So we also provide on-site, earthquake early warning solutions as well. So these sensors can pick up the P wave arrival and really quickly, calculate the upcoming, the S wave, right, the strong shaking of the earthquake, and notify the user, right, with the like LED lighting, with the siren, and has also relay, like the contact relays that signal can be taken and automate like the certain actions, right? So the gates can be opened automatically, or the elevator can come to the nearest floor, open the door automatically. For a dam, the spillway, the gates can be like fully automated, can be opened with the earthquake early warning as well. So there are many different ways of using the earthquake early warning signal, like for all these like autonomous the actions, right? And then we also send immediately text alerts to the users about the incoming earthquake. So this is our like basically earthquake early warning system. So in terms of the the business model, the way that we are working is we provide software and hardware. So we work with the multiple companies to provide the hardware as well, but our main core, like as a company, is the software, right? And so it depends on the structure. So this is the range that we've been basically providing solutions, like from very simple dam monitoring for a couple of $1,000 to the major suspension breach, the monitoring. So this is kind of like the range in terms of the software and hardware. And for the software part, we have multiple options to offer. We like to, as a company, we would like to provide this as a service. It's like a subscription, right? For annual, the licensing. So this way we keep the cost, the minimum for the user. And during this, the licensing period, we provide 24/7 monitoring. We provide all the updates, the free. Like we are available always for any technical, if they any technical questions. So we like to work with the client closely, like instead of just the selling the software and the going away. So that's the model that we don't want to do that. So we like to work with the client closely to provide the best solution. So and then we want full satisfaction from our from our clients, right? So this is kind of like the the licensing our annual fee for this, for the software. Again, depends on like how complicated the system and how many like a different kind of like the sensors the structure has. But the minimum is around So I'm gonna like wrap up. So this way, if there is any questions, then we can talk about it. The one of the area that we started working is we collaborate with Testia from Germany. Testia is an Airbus group company. So together, with Testia, we are targeting different fields, especially the wind turbine, like the monitoring the wind turbines, right, and also bridges. I want to talk a little bit about the bridge project that I mentioned in Nevada. So this is the world's largest concrete arch bridge. This is a joint effort between Quakelogic, Georgia Tech, and University of Nevada, the Las Vegas. So it was like a joint venture project, and then we just completed this instrumentation. We put 45 sensors in the structure. So this is the team. We work with students. Basically, we didn't hire any contractor. So students came to the bridge site. They pull all the cables. So we provide the know-how and how we show them how to install all these, the sensors in the structure. And on the right side, so you can see all the digitizers, and we do have 2 structural health monitoring, the servers running on the abutment of the bridge. The other project that we recently finished, this is the railway bridge in Switzerland, that they use very specific like new technologies, new material for the deck, and then there are about close to 40 sensors with strain gauges, the laser displacement sensors, accelerometers that collects data on site, and then we provide the structural health monitoring software. Every time when the train passes, it triggers the system, and we do all the processing, and then the data goes to the dashboard, and we even count like how many cars the train has, and then which way the train is actually the passing from the right crossing or left crossing. So these are a couple of snapshots from our web application, our dashboard. The opening page, we show all the most recent earthquakes around the globe. Everything clickable, so you can click and see the magnitude of the earthquake. We pull the data. Every time when you open the dashboard, it pulls the most recent data from the USGS. And then for each structure, we provide a dedicated page, right? And at those pages, so we have all the facility information, who is the contact person, what kind of like geotechnical details, what are the the seismic hazard conditions, right? And seismic design values. And we also have tabs for the reports, right? Everything, all the reports comes to the dashboard. Everything is the timestamp and color coded based on the the level of the alarm. Same thing for the data as well. Our system provides the action items, as as I mentioned. We also have another the module in the system that we can create 3D simulations. Let's say if there's the shaking happened in the building, right? So our system can create those 3D animations, so you can see how our structures actually the move during the earthquake. You can see the entire 24 hours of recordings from each channel of the sensors. For each sensors, this could be the accelerometers, temperatures, the wind sensors, so you can see everything, and then those plots update itself every 5 seconds. And we also have multiple panels showing the sensor data real time, right? So this is one example. So this is a nice display that show all the sensors like at certain locations. So data update itself every 3 seconds. The window on the left corner is showing actually all the the recent earthquakes around the structures. So this can be like LCD on the LCD screen, right? It's open all the time. It could be like in the control room that you can see exactly what's happening with your structure with this monitoring system. So this is like overall my presentation today. And
Thank you very much, Dr. Kalkan, for sharing your knowledge in structural health monitoring and earthquake early warning systems. Thank you. Thank you very much for your time and explanations. So, we will conclude this session here. And thank you everyone for joining this talk.